Hey, welcome back, guys. So this is where we left off, and this was one of those really frustrating assignments because adding up all these little square units on the inside of both of these circles was pretty tedious. Took a long time, and I admit it would have been a lot easier to do this if I had just given you this formula right here. A equals pi r squared. That is the area formula for a circle, and you can see more than anything is that the only thing you need to know about a circle to find its area is its radius. So as we go back here and take a look at this, you can find the radius pretty easily by just finding the center right here and then counting how many units there are to the side of the circle. So this would be 1, 2, 3. So this has a radius of 3, and this one down here has a radius of 1, 2, 3, 4, 5, 6, 7. So all you have to do is take those numbers and plug it in right here, do that arithmetic, and voila, you've got yourself an answer. Pretty simple. But I don't want you to take Google's word for it. This is something I just screen clipped from Google. I really want you to see where all this came from. And that's kind of the point of today's lesson. And it's what you would have done had we been in school too. All right, here's what you need to know. Every area formula is derived from the rectangle because the rectangle is the easiest area to find. All you need to know is its width and its length. And to find the area, I know you've seen this before, you probably did it in early elementary school. Area is length times width. Now what I would have had you guys do had we been in school is I would have given you these circles right here. I'll explain that yellow highlighting in a little bit. But you can see this circle is broken up into 4 pieces. And then this circle down here took those 4 pieces and split them in half. So now there's 8 pieces. And then, I don't know if I split these in half again, but they're definitely equal pieces. They're split into equal sizes. And then these ones were split again into even smaller ones, like this. And so what I would have told you to do is to try and turn those circles into a rectangle, because we know the formula for a rectangle. So make the circles look like a rectangle. Sounds like an impossible task, but it really is not that hard. So I want to show you what we would have done. So I made 2 copies of this just to try and make it go a little bit faster. But I would have given you this. There you go. Now you can see those little lines right there. And I would have given you some scissors and some glue sticks. And I would have asked you to cut these along those lines. So I'm going to cut this thing up into 4 pieces. All right, got it. So our job would have been to take these 4 pieces and turn it into a rectangle. Now this is the best that we can do at this point. Make 1 point up, make 1 point down, make 1 point down again, and then make the other one go up. All right, now take a look at that. I don't know if I'd describe that as a rectangle. In fact, I don't even know what kind of shape that is. Let me zoom out a little bit. There we go. All right, so we said, okay, let's move this guy out of the way. And let's take a look at this guy. All right, this one's cut up into smaller pieces. There's 8 of them. All right. got it. So we would have done the same thing. All right, let's make 1 point down, make another 1 point up, make another 1 point down, make another 1 point up, and we'll just keep that pattern up. All right. So, again, I'd say it looks a little bit more like a rectangle than the other one did. All right, this one is the one we did last time. This one you can see that there's so much waviness right here going along the top, but the waviness gets a little more tame as I cut these things up into smaller pieces. All right, let me move this out of the way. And now let's see what happens when I cut this one up into pieces and I cut this one up into pieces and do the same thing I did before by making one piece point up and one piece point down. So the reason I highlighted all of the outside is because the yellow part is going to represent the circumference. This is going to come in pretty handy when we start doing the substitution. And then on every single one of those circles, I just highlighted one of the radii. These are all radiuses right here. I just highlighted one of them. And this orange is going to represent the radius. So let me pencil that in there. And let me pencil that in right there. And then I'm going to cut these guys up into pieces as well. And do the same thing I did last time. Now don't worry. You're not going to have to sit here and watch me cut all those things up into pieces because I already took the liberty of doing that. So, that third one that was cut up into 10 pieces, that's what this one would look like if I cut it up into pieces, making 1 point up and 1 point down. And you can see the top is becoming even less wavy now. It's starting to become more of a line than anything. And there you can see is the orange radius that I'd highlighted. All right, here we go. Check this one out. Now the one that was cut up into the most pieces looks like this. Now there's a ton of human error here because I didn't have a glue stick. So this one that popped out right here wasn't supposed to pop out. It should have been in line right there. But you can see, again, as I cut it up into smaller and smaller pieces, the top starts to look more straight and the pieces in general start to look more like a rectangle. So what we would do in theory is if we kept cutting these in half and then we took those halves and we kept cutting those in half and we took those halves and we kept cutting those in halves and we just did that all the way to infinity, that eventually this roundedness would go away and this width right here in orange would become more and more and more vertical, which in turn would turn it into a rectangle, which is what we wanted to do. So let's take a look at the dimensions here. This dimension right here, this would be the width, and then this dimension right here, this would be the length. Now, we already know that the area formula, let me zoom out just a little bit, is equal to length times width. Now that's not going to work for a circle, or at least for the formula that we got, because the formula that we got looks like this. A equals pi r squared. And that doesn't say A equals pi r squared. There's no pi or r or anything like that in there. So let's try and make that happen. All right, so this is where our clues come in. What I want you to notice is, if you remember from the beginning, I highlighted the entire circumference. So what you see is the circumference is lining the top of the rectangle and the circumference is lining the bottom of the rectangle. So half of them went down on the bottom and the other half of the circumference went on the top. So what I'm going to do is I'm going to say, instead of calling this the length, I'm going to call this half the circumference because that's what got highlighted across the top right here. That was both of them combined would be the circumference, but just the top itself would be half the circumference. Now the width over here, we're going to substitute that as well with whatever the orange is. And if you remember correctly, we highlighted the radius in orange. So I'm going to make this say R. All right. So in the place of W, I'm going to put an R. And in the place of the length, I'm going to put half C. All right, let me get a blank piece of paper because we're going to need some room. All right, so just like we did last time, I'm going to do a little substitution. The length, as we can see, is now going to be called half circumference. Then there's a multiply sign, so I'm going to bring the multiply sign down. And then the width, you can see over here, we're going to call that the radius. All right, so take a look right there. We've got this new rule that says half the circumference times R is going to give us our area, the area of a circle. Now, let's be really clear. This would work. All right, if you knew the circumference of the circle and you knew the radius of the circle, you'd be able to find its area. But again, that's not what this says. We're trying to get this final formula to look like the one that it says on Google. All right, so let's go back there and keep going. All right, what can we replace? Well, we don't want to replace that R because we know that we want that. We saw that on the Google slide. We want the radius in there. But it didn't have anything about circumference in there, so I think it's the circumference that we're going to want to substitute for. Now, if you remember correctly, here are some old notes. Take a look at this. We did this a couple days ago. We said that circumference is the same thing as the diameter times pi. So let's do some substitution. In the place of circumference, let's put diameter times pi. All right, let's go over here. A equals 1/2 circumference times R. And we're going to do some substitution here. In the place of C, let's get rid of C. We're going to replace it with what circumference is equal to, which is d times diameter times pi. Diameter times pi. Okay, cool. Now I can get rid of that little box that I use, and I end up with, let me just write this over again just because I think it looks extremely messy. Area equals 1/2 times diameter times pi times R. All right, cool, we did it. This would work. If we know the diameter and the radius of a circle, we can find its area. But once again, that is not, where did it go? There it is. It's not what this says. We want it to say A equals pi R squared. So let's keep going with the substitution a little bit further. Now, if you'll notice on that Google slide, there was no variable for the diameter. So the diameter is the one that we're going to want to replace. Now, if we go backwards into our notes again, what we're going to remember is that the diameter is the same thing as twice the radius. So that's where I'm going to do some more substitution. I'm going to replace the diameter with twice the radius, or 2r. There's the diameter right there. I need to replace that. Replace that diameter with 2 times r. Then we'll continue with the times pi, and we'll continue with the times r. All right, we are almost there. We're almost there. This is still a mess, but because everything is being multiplied, that means that I can use the commutative law and start moving these around in any order that I want to. So here's what I'm going to choose to do. I'm going to leave those the way they are, and I'm going to switch these two right here. I'm going to make the pi go second. I'm going to make the radius go after that, and then don't forget about this radius right here. All right, cool. Here we go. Now, if I do this arithmetic right here,